Up to this point in the unit, we have been looking at just solving proportions in general. We've looked at a few extended ratios, some word problems involving proportions. But now we're going to learn why were we learning about proportions? Why did I need to make sure you knew how to solve them? How does that apply to geometry? How are we using that idea in this unit of similarity? And this is where it's going to start to come up to today, is we're going to be dealing with the ideas of both ratios and proportions in today's lesson in determining what are similar polygons and what is scale factor. So starting with the idea of similar polygons, any two polygons are similar if their corresponding angles are congruent and the measures of their corresponding sides are proportional. So angles are going to be congruent, sides have to be proportional, hence one of the reasons we had to learn about proportions, because we're going to be applying them here with similar polygons. So the first set of examples here are saying, state if the polygons are similar. Again, to say they are similar, they have to meet two criteria. The corresponding angles have to be congruent, and the corresponding sides have to be proportional. So we're going to talk about what that looks like. Now, in the first example here, they're giving me two parallelograms. To know the properties of parallelograms, both pairs of opposite angles are congruent. So if the angle in the bottom left is 75 degrees, the angle in the top right is also 75 degrees. And that applies to both diagrams. And if we have parallel lines, and I'm looking like along the 21 and the 14, those would be same side interior angles. And we know same side interior angles are supplementary when the lines are parallel, which means that I would have to subtract the 75 from 180 and know that this angle is 105, but then its opposite angle would also have to be 105. So when I look at that, the first criteria, are all the corresponding angles congruent? And yes, I can look at the angle in the figure on the left and match it up with the same place in the figure on the right, and they have the same measure. So criteria number one, all corresponding angles are congruent. So we've met the first criteria. The second criteria is that the corresponding sides have to be proportional. So if I pull one of the measures here, if I pull the 21 from the figure on the left, what number is going to match up with it on the figure on the right? Yeah, the 14 corresponds. They're in the same position. So in order for these to be similar, they're going to have to be in a ratio together. So we would set up 21 over 14. And we want to know, does that equal? I'm doing an equal sign with a question mark above it because I want to know, does that equal? And in this case, I only have one other set of measures here. I have the 12 that matches up with what? The 8. Now, important, we talked about setting up proportions before, and this is important here as well. that order matters. The first ratio, I went larger figure over smaller figure, which means my second ratio has to be set up in that same order. So I would have to set up 12 over 8. So I want to know, do those two ratios equal each other? How can I determine if they equal each other? Bless you. Just like we've been solving other proportions, we cross multiply. We want to know if I take 21 times 8, is that going to equal taking 14 times 12? If we are saying that they are proportional, those two multiplication problems should equal each other. So what is 21 times 8? $168. What is 14 times 12? 168. So are those two equal? Yes, they both came out to the same, which means the sides are proportional. So again, I said there was two criteria. The first criteria is that all the corresponding angles had to be congruent. The second was all the corresponding sides had to be proportional. We met both of those criteria here, so we can say, yes, the polygons are similar. We have showed that both of those are true. So again, corresponding angles have to be congruent. Corresponding sides have to be proportional. All right, so if we look at number 2. In number 2, they're using the arc marks to show what angles are congruent. So I don't have to know the measures. I can already see that the angles in the same position are congruent to each other because I can match up one arc mark to one arc mark, 2 to 2, and so on. So I know that that first criteria here, all corresponding angles are congruent. Now I have to prove the second part, that all the corresponding sides are proportional. This one is a little different. The last one, I only really had 2 measures to match up. Here, I'm going to have more than that. So if I start with the 15 in the top figure, what does it match up with in the bottom figure? The 24, they're in the same position, so we would say they are corresponding. So one of my ratios is going to be 15 over 24. What does 12.1 match up with? The 21.5, so that's going to be another ratio, 12.1 over 21.5. But I have a third one here. I don't have to worry about the side on the right because it's the same as the side on the left. But I have the 24 at the bottom of the first figure. What does it match up with? The 40. So this time I have 3 ratios. Now I still want to know, are they equal to each other? But using cross products isn't necessarily the most effective way here, because I would have to do the cross products of the first 2, the cross products of the second 2, and then the cross products of the first and third. I would have to test all of those to see, do they all equal? When you're trying to compare more than 2 ratios, the easiest way is to reduce them down to decimals and compare their decimal. And the easiest way to turn them into a decimal is simply divide them. In your calculator, put 15 divided by 24. What do I get if I do 15 divided by 24? What is the decimal equivalent of 15 divided by 24? Yeah, 0.625. What about 12.1 divided by 21.5? What is the decimal equivalent? Yeah, and I'll just put 562. And what about the decimal equivalent of 24 divided by 40? Are those three decimals equal to each other? So I'm going to put the equal sign with the line through, showing they're not equal. And if they're not equal, that means the sides are not proportional. So even though the angles met their part of the criteria, the sides are not meeting their part of the criteria. So we would say no, the polygons are not similar. So again, we have to be able to meet both criteria to be able to say that they are similar. So don't just look at the angles and say, oh, the angles are congruent, so they must be similar. You have to be able to show that the sides are proportional. And again, whether you can use cross products to show that, or whether you have to reduce them down to decimals to compare, you have to be able to show that. Now, the next idea that also comes up in this section is the idea of scale factor. Now, we used scale factor when we were doing our dilations earlier in the unit. But what is scale factor? And scale factor is the ratio of any two corresponding sides into similar figures. So the scale factor is really what measures one figure to the next to determine that they are proportional. When we were determining above, we were looking at those ratios. Were those ratios equal? In the first problem, if I had just reduced the fractions down instead of using cross products, if I had reduced those fractions down, 21 over 14, 7 goes into both of those, so that would be 3 over 2. 12 over 8, 4 goes into both of those, would reduce down to 3 over 2. So the scale factor there would be 3 to 2. It's what are those ratios? And what does that mean? So when we're looking at scale factor, we also have to pay attention to the order that they are asking for. We talked about this in the word problems. And this applies to scale factor. If they ask for the scale factor in a specific order, which the pretest that you guys did a couple weeks ago did ask for a specific order. In that case, in that specific order, you have to make sure. Some people understood the idea of scale factor as to relating the sides, but did not give it in the correct order. So for what we're doing, most times it'll ask for the smaller figure to the larger figure. And again, if they ask for the smaller figure to the larger figure, that means the smaller figure number goes on top and the larger figure number goes on bottom. Whatever they mention first becomes our numerator. What they mention second becomes our denominator. Just like we had in those shadow word problems. The order mattered. So here I have a lot of different measurements to look at. So let's just use the 6.65 and the 3.5. When you are doing scale factor, you just have to match up one set. Even if they give you all three, you'll only have to match up one. So in our diagram, if I'm doing the scale factor here, and again, I want to go from the smaller figure to the larger figure, that means I have to start with the 3.5 on top. The 6.65 is on the bottom. Now, to find its scale factor, I have to be able to reduce this. Now, if you leave it in decimal form and you put it in your calculator, it's going to give you a decimal back. But anytime you have decimals in a fraction, you can multiply them out. I need to move the bottom one 2 decimal places. So technically, I need to multiply these both by 100. In doing that, I get 350 over 665. If I put 350 divided by 665 in my calculator, what fraction does it tell me that that reduces down to? And this is only if you have math mode. If you don't have math mode, you would actually have to reduce it manually. But if our calculator's in math mode and I put 350 divided by 665, what is the fraction that reduces down to? 10 over 19. But what does 10 over 19 mean? What is that telling me? The scale factor, that 10 over 19, is telling me for every 10 units in the smaller figure, there are 19 units in the larger figure. So again, that scale factor is giving me information about that figure. It's not just some ratio out there. It's telling me how they relate to each other. Now, the scale factors that we were using in dilations, one of them we used a scale factor of 3, which meant it was really a 3 over 1. So for every 3 units in one figure, it was 1 unit in the other. Any whole number, remember, can be turned into a ratio by putting it over 1. But again, one of the biggest ideas is we have to pay attention. What order are they asking it for? Sometimes they may ask for larger to smaller. Other times smaller to larger. You have to make sure that you are paying attention and answering based on the order that they were asking for. So on the next page is where we're going to have some examples where we're going to put this into practice here. So they tell us the polygons in each pair are similar, which is important because we can't do scale factor if the polygons aren't similar. So scale factor, we have to know that the polygons are similar. And then they tell us, find the scale factor of the smaller figure to the larger figure. So again, we know that our numerator is going to be the smaller number and our denominator is going to be the larger number based on how they asked for it. Now again, when I am doing scale factor, I am only comparing one set of numbers. Even if they give me all these other numbers, I just have to pick out one pair of corresponding sides. Now, in the case of this diagram, we have two squares, and I know they're squares because the sides are equal. So I only have one set of numbers to match up. I have the 9 in the smaller to the 12 in the larger. Again, the smaller number is going to go in my numerator. The larger number in my denominator. But in this case, I get 9 over 12. Ratios always need to be reduced. Both of these are divisible by 3. So this reduces down to 3 over 4. So my scale factor would be 3 to 4. And I am going to put a little note here. Must reduce if possible. But you also have to make sure you are matching up corresponding parts correctly. So again, number 4, we're still doing smaller to larger. That was the order they asked for in the directions. So we're still doing smaller to larger. So again, I only have to match up one pair of sides. And actually in this diagram, there is only one pair of sides I can match up. What are the two numbers that are in the same place on the diagrams that I can match up in this case? I'm sorry, I couldn't hear that a little louder. Yeah, 15 and 18 are the only ones. The 30 and 40 are not representing the same parts of the diagram. But again, they want smaller to larger, so my scale factor in this case, I have to start with the one on the right, the 15 over 18. I need to make sure I'm doing smaller to larger. And again, 15 and 18 are both divisible by 3. So I do need to reduce them to 5 over 6. Now, the other way we're going to use this information, knowing that the polygons are similar, and knowing that if they are similar, the sides are proportional, is to solve for missing parts. So it tells us in the next directions, the polygons in each pair are similar, find the missing side length. Now, I can see the one that is missing. I can see the question mark. I'm actually going to turn that question mark to an X. what measurement in the top figure matches up with where the x is in the bottom figure? 3. So it doesn't, and here it doesn't matter how I write the first ratio. I can write the first one 3 over x. How I write the second ratio matters based on how I wrote the first one. Because I did the top figure over the bottom figure for the first ratio, the second ratio I have to do the same. Now, I do have to caution you here. This one, a lot of mistakes are made because the way these figures are drawn. It looks like I can go straight up. But you have to look at the measurements of the sides that are left. On the top figure, I have a 5 and a 5.1. The smaller of those two has to match up with the smaller of the two measurements on the bottom. So what would the 5 match up with if it has to match up with the smaller measure on the bottom? The 15. So be cautious. Don't just go straight up or straight across. It's hard to tell, but they actually flipped the bottom figure, which means the 5.1 matches up with the 5.3. Now, they're giving me more information than I need. I only need 2 parasites here. They're giving me 3, which means I have a choice. I know I have to use the 3 over x. I'm going to choose to use the 5.1 over 15.3. I could use the 5 over 15. Either way. Now that I have my proportion set up, now we're back to the beginning of the unit. Solve the proportion. How did we say we're going to solve proportions? We're going to use our cross products. I'm going to start with the 5.1 times the x. And that's going to be equal to the other diagonal of 3 times 15.3. But the biggest part, if you don't set up the proportion correctly, you can't get the correct answer. So here we get 5.1x equals, what is 3 times 15.3? 45.9. And if I divide both sides by 5.1, what does x equal? 9. So based on that, the sides being proportional, that missing part would have to be equal to 9. Now, another way that they will give you the same type of problem on the next page is they'll use the idea of a figure A and a figure B, and they'll give you a scale factor. So if we look at the next example, they give us a figure A, a figure B. Again, I am going to change that question mark to an X. But it's very important, this statement here. Scale factor from A to B is equal to 2 to 3. That statement there means A to B means A in the numerator, B in the denominator is equal to 2 in the numerator, 3 in the denominator. Now, the reason that's important, I can replace the A and the B from the measurements from those figures. But it's important to notice A is the figure on the right. We're going from A to B. So you need to make sure that you're setting up the measure in this case to match up, replace the A would be the value of x. So we're going to have x over, and the B is going to get replaced by the 9 because that is the number. So x over 9 has to equal 2 over 3. And again, once I have the proportion set up, now it's back to solving by my cross product. So I'm going to start with my 3 times x is equal to my other diagonal of 9 times 2. So I get 3x equals 18. And if I divide by 3, what does x equal? So based on that scale factor, that missing side length would have to be equal to 6. Now, the only difference with the next two examples, 7 and 8, we're still solving for x. The polygons are still similar, is we're going to get into expressions instead of just a single variable. So the same idea we were just doing, but instead of having a single variable that we're solving for, now they're giving us an expression to solve for that variable. And again, a lot of the diagrams are going to give you more information than you need. Now, I know I have to use the 2x minus 6 because I'm looking to solve for x. What measurement in the top figure is going to match up with the 2x minus 6? The 8. So that is going to be one ratio. I can write 8 over 2x minus 6. Now I have to be able to match up one more pair of sides. Both figures have 2 more measures, but only one pair of them matches up as corresponding. What are the 2 numbers that match up that I need to use for my other ratio? 6 and 9. They're both in the same position in the diagram. So my other ratio on the other side of the equal sign would be 6 over 9. And again, the first ratio, I went the top figure to the bottom figure. So the second ratio has to follow that same order. Top figure to bottom figure. And again, once I have my proportion set up, then it's just back to solving a proportion. I'm going to start with my cross product of 6 times 2x minus 6 and equal that to my other diagonal of 8 times 9. Now that I'm dealing with a expression, I do have to distribute, so I have to make sure and take that 6 times both terms. So I have 12x minus 36 equals 72. Add the 36 to both sides. We get 12x equals 108. And if I divide both sides by 12, what does x equal? 9. So again, using that idea of the figures being similar, which uses proportions to solve, because if the figures are similar, the sides have to be proportional. And again, they're going to give us an example using just the A to B, like in number 8 here. So they tell us the scale factor is from A to B is 1 to 3. So A over B equals 1 over 3. This time the A is on the left, so we're going from the left to the right this time. I'm going to replace the a with the 2x minus 19. And I'm going to replace the b with the 9. So 2x minus 19 over 9 equals 1 over 3. That is the proportion that I'm going to solve for x. So start with 3 times the quantity 2x minus 19. And equal that to my other diagonal of 9 times 1. And again, because I have an expression on the left, I have to make sure and distribute. So I get 6x minus 57 equals 9. If I add 57 to both sides, I get 6x equals 66. And if I divide both sides by 6, what does x equal? X equals 11. But again, if you don't set up the proportion correct, you cannot get the answer correct. So it's about taking time and making sure you are setting up that proportion correctly so that when you solve, you are getting the correct answer.